Hello and welcome to today's lesson. In today's lesson, we are going to look at a topic called chemical bonding. So, what is chemical bonding? So, chemical bonding is the joining of two or more atoms chemically. The joining of two or more atoms chemically is what is referred to as chemical bonding. The most important question to ask ourselves is why chemical bonding? So why are these atoms undergoing the process of chemical bonding? So atoms undergo the process of chemical bonding in order for them to become stable. So they undergo the process of chemical bonding in order for them to become stable. What does stability mean? So stability means either satisfying the octet or the duplet rule. So what does this mean? So octet simply means when you have 8 electrons in the outermost shell or the last shell. Then duplet means when you have 2 electrons in the last shell. So atoms will undergo the process of chemical bonding in order for them to have a noble gas configuration. So the whole idea of atoms undergoing the process of chemical bonding is for them to become stable. We're going to give more details to this. Then we have to know the types of chemical bonding that exists. So we have what we call ionic bonding, which is also known as electrovalent. We have covalent bonding, which is also known as molecular bonding. We have what we call metallic bonding. We have what we call hydrogen bonding. Five, we have what we call coordinate, which is also referred to as dative covalent bonding. Then lastly, we have what we call the van der Waals. So under the van der Waals, we have two types. we have what we call the London dispersion force or forces, and we have dipole. So these are the types of chemical bonding that we have, and we're going to look at them one by one. So in this video, we are going to focus on ionic bonding. So what is ionic bonding? So ionic bonding is a type of chemical bonding that involves the transfer of electrons from a metal to a non-metal. So if we were to look at the visual representation of this, so we have a metal and we have a non-metal. So this involves a transfer of electrons or an electron depending on the valency number. So electrons will move from a metal, meaning metals will lose electrons according to their valency number. Then non-metals will gain electrons according to their valency number. Let's quickly look at examples. So examples say demonstrate ionic bonding in the following using dots and cross diagrams. I'll give an example of sodium fluoride. So the first thing is step 1. In this case, if I'm not given the chemical formula, then I have to write the chemical formula. So sodium, valence number is 1, fluorine, the valence number is 1. When equivalences, we have equivalences, they'll cancel, then the formula is this. So that's the first step. Step 2, I need to know how to write the atomic structures of what is involved. So in this case, there is sodium with an electronic configuration of 2, 8, 1, and there is fluorine with an electronic configuration of 2, 7. So when I look at this and I draw these structures like this, then allow me to use a different color for fluorine. That's 2, 7. So those are their atomic structures. So even before I demonstrate the bonding, I'm able to see that for these guys to become stable, a metal should lose according to its valence number. So that becomes that with a 2,8. Then that should gain according to its valence number. Then it becomes 2,8. And both satisfy the octet. So there's a transfer of this one electron to that. And this is the electron that will be transferred to that. Therefore, my final structure will be sodium 1, 2, then with 8 electrons in the last shell, and I'll have this to show that it's an ion now. Then fluorine becomes a fluoride, so with those 7 then gains 1, so this becomes this. So we are able to see that the new configuration now is 2,8, 2,8 from 2,8, 1 to comma. So in this state they are unstable, but once they undergo the chemical bonding they become stable. They are both satisfying the octet rule. Let's look at another example. What of a case where we are given lithium oxide? So the first thing is to write the chemical formula. So lithium, valence number 1, oxide, valence number 2. With interchange, it becomes this. So this tells you that you have 2 lithium, 2,1, and 1 oxygen, which is 2,6. So even before I draw the atomic structures, I have an idea of what is going to happen. So this will lose according to its valence number, which is 1, 1. Then this should gain according to its valence number. So that one will go there, and that one will go there. So when I look at the structures, I'm going to have this with 2,1 and another lithium 2,1. Then I have the oxygen, which is 2,6. So remember, the valence number for oxygen is 2, meaning that oxygen is supposed to gain 2. So that will transfer 1, and that will transfer 1. So ultimately, this becomes 1, 2. We close, show that, then that 1, 2, positive, then oxygen 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. To show those it has gained, then you put the 2 negative. Or you can write a condensed formula of this. So a condensed formula of this is, instead of drawing these 2 here, you can just say 2, and then you draw 1 like that, and then you indicate positive, then you draw the oxygen on the other side. This still represents the same thing as this. Let's look at one last example. What of a case where we're given aluminium sulfide? So aluminium sulfide is aluminium valence number 3, sulfide valence number 2. When we interchange, it becomes Al2S3. So this tells us that we have 2 aluminiums with 2,8, 3, 2,8, 3. Then we have 3 sulfur, 2,8, 6, 2,8, 6. 2, 8, 6. So how do we demonstrate this bonding? So we have aluminium with 1, 2, 1, 2, then another aluminium, sorry, 2, 3. Okay, then we have 3 sulfur. So we have sulfur 2, 8, 6. So they are coming from group 6, meaning they have to gain 2. 2, 6. Then another sulfur. So we have 3 sulfur atoms. Okay, so what happens in this case is aluminium will lose according to its valency number, and its valency number is 3. But this is how it's going to lose. So these 2 will go there, then these 2 can come here, then this one and that one will go there. So what happens is sulfur is supposed to gain 2 each to become 2, 8, 8, 2, 8, 8, 2, 8, 8. Then aluminium will lose 3 to become 2, 8, 2, 8. Therefore, a condensed formula for this becomes 2, 2, then aluminium, so 2, 8, stable, then I say 3 plus, then 3 of the sulfur, 2, sorry, here we're using dots, then the last shell, so sulfur gained 2, then 2 negative. So that is the final structure that we're going to have. So ionic bonding results in the formation of a crystal or a crystalline lattice. So a crystalline lattice is just a 3-dimension arrangement of particles. It's a regular 3-dimension arrangement of ions. So we see something like this: negative, positive, and then goes down there, positive, negative, positive, negative. Yeah, so something like that. And it carries what we call the electrostatic force. But what is existing there is just an ionic bond. So we see something like a positive, negative, negative, positive type of arrangement. So in 3D, this is what we have, and it's called a crystalline lattice. Alright, we'll talk about the other types of bonding in the next video. Bye-bye.